Hello everyone. Here we have joined. We have three brilliant young minds. Who has done their work on AI for social-driven crypto pricing. It's an exciting new frontier. It's where the technology meets the market dynamics and community sentiments. Okay, so let's hear what they have to say. I will let the presenters do that.
Good evening, everyone. Today, me, Angad, Abhinav, and Jivin will be presenting our research work on AI for social driven crypto pricing. And we have done this project under Chinta's AI Research Lab. Next slide, please. So, in this project, we basically worked with cryptocurrencies. And since cryptocurrency prices are highly volatile and they're sensitive to online sentiment, it was a good project for us to work on. Since they're highly decentralized, it means that the market dynamics often depend on public sentiment. In our project, we basically work with Bitcoin. Since Bitcoin is the most popular cryptocurrency out there, we aim to analyze how cryptocurrency news headlines influence Bitcoin price direction. This project has significant impact on individuals and communities globally, and understanding what moves crypto prices can help us reduce panic driven trading behaviors. Next slide, please. So, here is our problem statement. So, given the historical price data and Bitcoin related headlines during the previous capital T trading days, which is a time window over the day range small t minus capital T up till small t minus 1. This will we will refer as a look back window. We define the price movement of Bitcoin from the day t minus 1 to day t as a function yt, where it is equal to 1 if the price increases and it is equal to 0 if the price decreases. So, for example, if the closing price of today of Bitcoin is 100 rupees and then tomorrow it's 101, then yt will be 1 since the price has increased by 1 rupee. We'll then do a sentiment analysis of the past T headlines and classify the price movement based on the aggregate sentiment of the entire day. So next slide, please. Some work has been done on this topic, and we'll quickly go through over it. So Palmo from Stanford's Department of Computer Science used FinBERT, which is a AI language model specifically trained on financial documents, and he FinBERT and random forest. So random forest is also a machine learning method that uses decision trees to make predictions. He found that FinBERT along with random forest gave the best possible prediction model. He used tweet sentiment to predict stock prices. Next, we have Froman and others. They compared simple models like linear regression to LSTM. Here, LSTM stands for long short term memory. It is a special kind of neural network that is good at learning from data spread over time. For example, it can predict future trends from past stock prices or tweets. And he found that these simple models, like the linear regression, often perform better. Now we have Romel Louis and others. They compared FinBERT, GPT-4, and BERT for financial sentiment, and they found fine-tuned domain models work the best. Then we have Tang and others. They combined edit sentiment with LSTM for price prediction, and they achieved high accuracy, but their work required heavy computation. Now we have Sarafani and others. They showed Arimax, which stands for autoregressive integrated moving average with exogenous variable. So basically, that is a traditional statistical model which is used for time-based data like prices, especially when they are influenced by external factors like news sentiments. And he found that Arimax outperformed deep learning models like RNN, where RNN stands for Recurrent Neural Network. It is a neural network which is designed for sequence data, where past information is used to understand or predict future events. Finally, we have Rahman and others. He found that he basically compared 22 sentiment models and we found that the Agents Plus model showed strong correlation with crypto price movement. So Agents Plus is a sentiment analysis tool which is specifically designed for analyzing financial and cryptocurrency related texts. Next slide, please. So let's come to how our project is different from what they have done. As you would have seen before, the existing work on this cryptocurrency and their sentiment analysis often uses complex black box models, and they often only vary a single variable like the sentiment model or the classifier. We instead tested the models and classifiers separately to identify the best performing combination. Next slide, please. Now I will hand it over to Jivin.
Right. So here's an overview of our methodology showing the key steps that we followed. We first collected Bitcoin related news headlines. After that, we filtered the collected data to ensure that it matched our needs. We then ran sentiment analysis on the filtered data using two models, FinBERT and CryptoBERT. We calculated daily aggregate sentiment scores, after which we fetched Bitcoin closing price and assigned binary labels to each date based on the price movement. Then, with all the data processing done, we started prediction. Next slide, please. We had divided our data set into two main parts: training data, which had 1700 days of headlines, which we had collected by utilizing a data set that we found online, and testing data, which had 26 days of real time headlines collected via the CryptoPanic API. We had automated the data collection process for the testing data using Google Apps Script early, which meant that we didn't have to intervene and the data would get collected automatically. We then filtered the collected data and included articles that were related to Bitcoin and excluded any articles that didn't have credible sources. Next slide, please. For sentiment analysis, we used two models, FinBERT and CryptoBERT. FinBERT and CryptoBERT both are finance-related sentiment models, but CryptoBERT is more inclined towards cryptocurrencies. FinBERT is trained on financial reports, while CryptoBERT is trained on posts from crypto forums or posts from social media platforms like Reddit and Twitter. After we ran sentiment analysis, we got bullish, bearish, and neutral probabilities as output. We combined those probabilities to get a final score using the formula P bullish times 0.7 minus P bearish. So here we're modeling a risk-averse approach where we give more importance to negative signals than to positive ones. Our formula reflects caution, which is quite common in financial decision making, where avoiding losses is prioritized over chasing gains. We have an example output here. We have the title in the first column, the corresponding date, the bullish and bearish probabilities in the third and fourth column. We have the final score in the fifth column, which is just uh, obtained by combining the bullish and bearish probabilities using the above formula, and the aggregate sentiment scores, which is just the average of all the sentiment scores of a particular day. Next slide, please. So here's an example output that we got after we ran sentiment analysis using CryptoBERT. We have the price data in the first column, the aggregate sentiment for each date in the second column, and the binary labels that we assigned by analyzing the price movement in the third column. Next slide, please. This is an example output that we got after we ran sentiment analysis using FinBERT. This is similar to the CryptoBERT example output. So we have the closing price in the first column, the aggregate sentiment in the second column, and the binary labels in the third column. Next slide, please. For price labeling, we used CoinDesk API, using which we fetched daily Bitcoin closing prices. So we assigned binary labels to each date. One, if the price had increased or was equal to the price on the previous day, and zero otherwise. So this would help us to analyze the price movement without actually considering the magnitude of price change. At this point, we have two final data components, the aggregate sentiment scores and the binary labels. We will combine these and this will serve as the input for our prediction models. Next slide, please.
As Angad had mentioned earlier, all the other projects that we had looked at during our preliminary phase, they only varied one variable. So, what makes our project different is that throughout the duration of our research, we primarily worked with three different variables. The first one is the prediction model itself, the second being the sentiment analysis model, and the third being the look back window, or also known as the rolling window size. So over here, we can see the scores for different models of the prediction model. And out of this, out of all the models, we have chosen three for our research purpose. The first one being random forest classifier, the second being light GBM, and the third being XGBoost, which is a more fine-tuned version of light GBM itself. Out of all the three different models that we have worked with, we found that light GBM gave us the highest accuracy of 72% with an F1 score of 0.81. Light GBM is a model that is developed by Microsoft in collaboration with Peking University, and through our experimentation, we found that it gave us the highest accuracy. Next slide, please. Now that we have finalized our prediction model, we now move on to selecting a sentiment analysis model. As mentioned earlier, we had worked with two of them, CryptoBERT and FinBERT tone. Again, FinBERT tone had given us an accuracy of 72% with an F1 score of 0.81. CryptoBERT sentiment scores had topped, the accuracy of CryptoBERT sentiment scores had topped off at 70% at all instances, while FinBERT tends to perform better. We have also depicted the same in the form of a line chart in the next slides. Next slide, please. Now that we've also finalized our sentiment analysis model, we now have to decide an optimum size for the rolling window, or also known as the look back window. We employed a hit and trial approach, and we tested with variable window sizes. And from experimentation, we found that the rolling window size of 10 days gave us the highest accuracy of 85.7% and an F1 score of 0.9. Next slide, please. As Jivin had mentioned earlier, we have a testing data of 26 days. However, since we employed a rolling window approach, our model actually excludes the first 10 days and also the next 1 day. So out of 26, our data has now dropped to 14 days. Out of the 14 days, our model was able to predict the motion of a cryptocurrency price uh, for 12 days, the same which has been reflected in the calendar which has been displayed here. So this gives us an accuracy of 85%. Next slide, please. We can also see the confusion matrix for our model here with 10 true positives, 2 true negatives, and only 2 false positives. Next slide, please. The following graph depicts the variation in accuracy with the rolling window size for both FinBERT and CryptoBERT. As I had mentioned earlier, we can clearly see that the CryptoBERT, which is depicted in red, has topped off at 70% at its maximum. Whereas on the other hand, FinBERT has a bit more fluctuation but tends to show better performance for the rolling window size of 9 and 10 days, with the highest being at 10 days, which ended up being our optimum result. Next slide, please. We have also compared the F1 score versus the rolling window size for both the models. And the reason that we've done so is because F1 score takes both precision and recall into consideration. So it gives us a more ideal picture of which is the better model. As you can see from the graph, FinBERT overperforms CryptoBERT in almost every single scenario, that too by a very huge margin. So we were able to conclude that FinBERT was the ideal sentiment analysis model. Next slide, please. To conclude, among the tested combinations, FinBERT tone with light GBM and a 10-day rolling window performed the best with a high accuracy of 85.7%, outperforming all other models. Next slide, please. Our future work can also include incorporation of other sentiment sources like Reddit threads, Telegram channels, and news comment sections, as we primarily worked with limited social media posts and mainly focused on news articles. We can also integrate volume and volatility metrics to improve the context for our predictions. Future scope can also include the building of a live dashboard that updates predictions and sentiment scores in real time. Next slide, please. Our references for the project have been mentioned here. Next slide, please. Next slide, please. Thank you.
Okay, so that was some real good work. Awesome. So awesome project. So it's like a great example of how AI and social intelligence can shape up the financial markets, right? So big round of applause for them. So I will. So we have the comment section for any questions. So please feel to reach out to them.
Yeah, so there is no such questions as of now. It's just a congratulations that I can see from the YouTube channel.
Okay, then. So we can now stop here. Thank you, guys.
Yeah, so if anyone has any questions, you can comment it in this live session itself. I mean, it will not be live at that time, and we will have these guys answer it for you. Okay, thank you so much. Thank you so much, all three of you, and Shaif, to join and for this amazing session as well. So, okay, we will meet again soon, I believe. Bye.
Thank you.